Assalamualaikum, myself Sayyid Usama and my roll number is 21TE09. Digital Signal Processing Lab, Lab 7. Frequency Analysis of Digital Sequences. Lab Objective. The lab objective of this lab is to study digital sequences in terms of frequency spectrum, contribution of high frequencies in a sequence, contribution of low frequencies in a sequence. In lab report 7, we are doing two basic theory. First, we are doing basic spectral analysis. The Fourier transform is a tool for performing frequencies and power spectrum analysis of time domain signals. The second is spectral analysis quantities. Spectral analysis study in frequency spectrum contained in discrete, uniformly sampled data. The Fourier transform is a tool that reveals frequency components of a time or space-based signals by representing it in frequency space. The following table lists common quantities used to characterize interrupt signals properties. To learn more about the frequency Fourier transform, there are some quantities in this lab 7. Now you can see the task 1 of this lab, and you can see the source code of this task 1, in which we are doing first we are considering the sequence X, and then we plot the signals in MATLAB, and if simple frequencies in 2k samples per second, then we are doing redraw the sequence after removing frequencies above 5 kHz, and we observe and discuss the effect of this removal of frequencies, and in which we are doing the second is if we draw the sequence after removing frequencies above 7 kHz, and then we observe and discuss the effect of this removal of frequencies, and we are doing of these two methods in this source code. And now you can see the output of these signals. We are calculated origin signals and frequency spectrum, filter signals of cut of 5 kHz and cut of 7 kHz, and frequency spectrum after 7 kHz cutoff. In task 2, here you can see the source code of this task 2, in which we are doing first we are use the audio sequence, and then we use and we calculate digital Fourier transform. Now you can see the in the source code, and then we remove the upper half of frequencies, for example the frequencies above 4, and observe the change by listening the audio, and then we remove the lower half of the frequency below 4, and observe the change by listening the audio. Now you can see the output of this task 2. We are first we removing upper half of frequency. By removing this high frequency, the sound may lose its brilliance and clarity. The piano sound becomes softer and less sharp, with a smoother, less edgy tone. And then removing the lower half of frequencies. By removing these low frequencies, the sound loses its depth and richness. The piano sound may become thinner and less resonant, with a less impactful presence. Thank you very much.